You've been told the next pandemic starts in a crowded city, but the deadliest respiratory virus in the US plays by a different rule. NASA is tracking a pathogen with a 38% mortality rate that turns untouched, pristine geography into a kill zone. That's deadlier than playing Russian roulette with 2 bullets. The Earth has an inbuilt biological defense that uses weather patterns to trigger outbreaks, and NASA knows where it'll strike next. In March of 2026, a 60-year-old man checked into a Santa Fe hospital struggling to breathe. He hadn't traveled internationally, he hadn't moved through crowded transit hubs, he'd just been at home on his own rural property in northern New Mexico. Days later, the diagnosis came back: Hantavirus pulmonary syndrome, New Mexico's first confirmed case of the year. The man survived after days in the ICU. He was lucky. CDC mortality records show many patients don't leave the hospital, ever. That 38% fatality rate has held across more than 3 decades of tracking. Stanford Medicine places the long-term US average near 35%. Either figure places hantavirus among the deadliest respiratory illnesses routinely monitored in North America. There's no antiviral cure either. Once severe pulmonary symptoms begin, treatment becomes supportive. Things like ventilators, oxygen, and blood pressure support. The virus moves with frightening speed once the lungs begin filling with fluid. The Santa Fe patient only survived because New Mexico has 30 years of spotting the symptoms early. In states with little exposure history, early-stage cases are easily mistaken for influenza or pneumonia until respiratory collapse begins. But CDC surveillance records document another shocking trend. Since 1993, 94% of American cases occur west of the Mississippi River. Not most, but almost all. New Mexico alone has logged more than 140 confirmed infections. Colorado has more than 120. Arizona has exposure corridors across remote desert and woodland terrain. Then we look at the other side of the map. 10 states have never reported a single case. The list includes Alabama, Georgia, Ohio, and New Jersey, the states with the biggest, busiest cities. None of them have ever logged one. And then it stops. The distribution on the map falls off. Multiple states with massive population centers have never recorded a single confirmed case. The Santa Fe case is not unusual. It's pretty representative. The location changes, but the outcome doesn't. Low population, native rodent habitat, dry terrain, and limited medical access. In February of 2025, Betsy Arakawa, the wife of actor Gene Hackman, died of the same illness in their Santa Fe home. The exposure happened on a quiet, rural property with clean air and distant neighbors. Investigators later found rat nests in the outbuildings surrounding the property. It ticked all the boxes for the virus. And NASA is paying attention. The satellite could see what nobody else on the ground could. And this made all the difference. COVID spread through airports. Influenza spreads through offices. The cleaner the landscape appears, the more perfectly it suits the carrier system. Hantavirus does not fit that category. The main carrier in the US is the deer mouse. It's small, it's very cute, and seems completely harmless. In 1993, CDC teams trapped deer mice across the Four Corners region during outbreak investigations and found infection rates approaching 30% in some populations. The mouse doesn't get sick, it doesn't appear to develop symptoms either, and there's no mortality drop-off. That means there's no warnings to humans. The virus spreads through the mouse's urine, saliva, and droppings, an animal world sleeper cell that spreads infectious material through the environment. The University of New Mexico has since widened the threat map. More than 30 small mammal species in the state have tested positive for hantavirus exposure. The list includes ground squirrels, chipmunks, white-footed mice, and harvest mice. The carrier pool is not one species, it's a whole class of animals. In January of 2026, San Diego County reported a western harvest mouse had tested positive for hantavirus. Public health teams issued immediate warnings despite no confirmed human infections at the time. The carriers appear in places nobody expects. The mouse in your garage isn't the threat. It's the ones in the wide open spaces. The contamination builds up, and then the people arrive. There is a reason it works this way. In busy urban settlements, brown rats and house mice push native species out. They take the food and the shelter, and the deer mouse loses. Out in the wide open West, nobody pushes back. The deer mouse breeds against the limits of nature, not against the limits of a city. The American Southwest doesn't tolerate the conditions that help typical viruses flourish. The low humidity preserves the dried droppings longer. The sparse human footprint means the viral load builds over time before anyone interacts with it. The Santa Fe property, where the March 2026 case began, is exactly the kind of place where it thrives. The Hackman Arakawa home was the same, and the same applies to the workplaces in Mono County, California, where 3 people died in 2025. The cluster was flagged as unusual. None of those victims did anything risky. They lived and worked in landscapes that suited the carrier perfectly. The funding side of the equation makes it worse. Public health budgets, news coverage, and policy attention almost all flow toward dense, populated environments. The funding goes to mosquito control in Miami. The grants go to disease surveillance in port cities. The press goes to the next urban outbreak. Hantavirus sits in the opposite corner of that map. There are almost no headlines and almost no funded systems to push back. Geography dictates who is vulnerable. Researchers studying hantavirus exposure in northern Sweden found that people in rural forestry communities carried far more antibodies than nearby urban populations. Living in a different landscape had already changed how familiar their immune systems were with the virus before infections ever became severe. The pattern extends further than Sweden, too. A 2019 study across rural communities in Finland found the same immune gradient. People who had spent their lives in forested landscapes showed different antibody profiles than those who had arrived there from cities. The body learns from the landscape it inhabits. Move that body to a new landscape, and the learning resets to 0. In endemic regions, residents are often repeatedly exposed to the virus at low levels, allowing some degree of immune familiarity to build up. New arrivals, however, face the virus without that background exposure, putting them at a clear immunological disadvantage. That pattern repeatedly appears in CDC case investigations. In severe hantavirus infections, the virus does some damage to lung tissue, but that's not enough to kill the patient. The immune system does not recognize the threat fast enough. Then it overcorrects catastrophically. It floods the lung tissue with fluid. And it's that fight that kills the patient. In April of 2026, an Atlantic cruise outbreak followed the same trend. A passenger came down with a mild fever and a headache. The symptoms progressed, and just 1 week later, his lungs filled. He died that same day. The 86 passengers on that cruise had come from 23 different countries. St. Helena and Ascension Island, all remote spots. The carrier pool had been waiting in those places for years. A tourist's lungs walking off that ship were the opening. The virus is a bullet, and geography and biology are the weapons. In 2012, Yosemite National Park recorded a cluster of severe respiratory illness cases among visitors staying in Curry Village. There were 10 confirmed infections, 8 progressed to hantavirus pulmonary syndrome, and 5 required intensive care. 3 of them died. CDC and California Department of Public Health investigators later traced the exposure to a single structural design failure. The park had installed canvas-sided tent cabins with internal wall cavities insulated with foam. Those cavities became nesting grounds for deer mice, and by late summer, the population surged. The visitors did not get bitten. They didn't handle any rodents. They unpacked their bags, walked across the floor, opened a window, and dropped a suitcase on a bed. That was enough. Dried droppings inside the insulation broke into microscopic particles. The particles drifted into the cabin air. The virus stays viable in dried droppings for up to 3 days. Any surface that has hosted rodents long enough becomes a delivery system. The environment had already been loaded. Human movement triggered the exposure. Each breath carried it deeper, and the lungs did the rest. After the Yosemite cluster, the Park Service sent out alerts. About 260,000 visitors had stayed in the park during the infection window. They all got the notice. Health authorities in 39 countries got it too. The cabins were closed and torn down. 9 of the 10 cases were traced back to those rooms. The carrier doesn't need to be visible. The droppings do not need to be obvious. The ground just needs to have been lived in long enough for the dust to build up. Then it needs to be disturbed. The single highest risk thing a person can do is clean an enclosed space with a rodent problem. That includes sweeping a cabin floor, vacuuming a shed, or shaking out a tarp. It also covers moving stacked firewood, opening a barn after winter, or disturbing insulation. Each one of those can release enough particles to deliver a fatal dose. When the March 2026 case got announced, New Mexico's health department told residents not to sweep rodent droppings at all. Instead, they should soak them with a 10% bleach solution, pick them up with gloves and disposable rags. It's a recommendation, but it's one that's not enforced. Outside rural areas in the Southwest, the virus is still poorly known. The pattern of spread is consistent wherever the virus appears, and it tends to move in the same direction each time. In Argentina, the 2025 to 2026 hantavirus season has already produced 101 confirmed cases, double the amount in the previous season. The country has logged 32 deaths so far. A health alert issued in December of 2025 flagged the same pattern across the southern cone. The countries affected were Argentina, Bolivia, Chile, Paraguay, Brazil, Panama, and Uruguay. It's a common occurrence, and as the people thin out, the infection thickens. And it isn't confined to South America. Europe follows the same map. Sweden, Germany, and Finland all see yearly windows in the rural parts of the country. European Russia records 8,000 cases a year, mostly in forest country. Look at the clusters on a map. The empty zones produce the cases. The dense urban sprawls produce nothing. The deer mouse doesn't live in cities. Suburban Atlanta has plenty of rodents, and so do downtown Chicago and central Los Angeles. The hantavirus risk in those places is almost zero. The kill zones overlap with the destinations more often seen in a vacation brochure. The map runs from northern New Mexico to western Colorado and eastern Arizona. The European side covers northern Sweden and the Bavarian foothills. The Patagonian Lakes district anchors the southern end. The risk is not static. It builds because rodent populations aren't static either. They can surge, they can collapse, they can surge again. And those cycles are not random. They follow ecological triggers that operate on multi-year timelines, which means the terrain is periodically reloaded. But there's a deeper structure beneath the cycle too, something that determines when it all happens, and that is not local. The process that effectively weaponizes the ground is biological, and it unfolds in a sequence researchers can map step by step. It begins with a mast year, a period when conditions align and plants produce unusually large seed yields. Pinyon pines drop nuts, shrubs overproduce seeds, and grasses surge across the ground. For a brief window, the landscape looks transformed, and then the mice respond. A typical deer mouse litter runs 4 to 6 pups. A female can have 3 or 4 litters in a good season. In normal years, food and shelter put a limit on how many survive. In a mast year, that ceiling lifts. Reproductive cycles shorten and survival rates climb. Predators, the coyotes and owls and snakes, can't scale their hunting fast enough to keep up. Within a single season, a deer mouse population in a given canyon can double, triple, or even quadruple. In the build-up to the 1993 Four Corners outbreak, the count climbed roughly tenfold. Bob Parmenter, an ecologist at the University of New Mexico, first mapped the sequence and emphasized its timing. The delay between the vegetation surge and the rodent peak is measured in months. The system builds slowly, then suddenly reaches its peak. More mice means more droppings. More droppings means more aerosol. The carrier density inside the wild keeps climbing. Every hollow log, every wall cavity, every shed floor in the affected zone ends up hosting infected animals. The exposure risk jumps by an order of magnitude. In normal terms, a hiker in a quiet year walks past 1 or 2 mice per acre of pinyon juniper. In a loaded year, that number can hit 15 or 20. It happens time and time again when the conditions line up perfectly. The desert gets the rain, the plants respond, and the mice multiply. The droppings accumulate and the dust becomes biologically active. The 1993 sequence shows what a full run looks like. The wet winter of 1992 and 93 produced a record pinyon crop in parts of New Mexico. In the months that followed, deer mouse density in the affected canyons climbed beyond normal level. It was only a matter of time. On May 14, 1993, the first known patient collapsed on his way to a funeral in the Four Corners region. By then, the ecological chain reaction had already completed itself across the carrier zone. The virus had not mutated, nothing new had evolved, but the mouse population had simply crossed a critical threshold where spillover became statistically inevitable. The same underlying pattern, environmental shift, rodent expansion, human contact, has repeated with regional variations in every major surge year since. Compare what's going on here to other zoonotic threats. Avian flu needs a complex genetic change in a poultry livestock setting. Ebola depends on bat and primate contact patterns that experts still can't predict well. Lyme disease tracks tick density in fragmented forests, which keeps shifting. Hantavirus runs on a single chain. The cascade is on record. It happens time and time again, and it is not random. And the same ecological conditions that drive rodent surges are visible from orbit. In July of 2006, researchers associated with Johns Hopkins University and the University of New Mexico published a predictive model using NASA Landsat satellite imagery to forecast hantavirus risk zones in the American Southwest. The forecast did two things. It flagged the Four Corners core as the high-risk zone, but then it went further. It marked southern Colorado and north-central New Mexico as newly dangerous for 2006. Those places had been listed as low risk before. The cases that followed matched the map. It was the first peer-reviewed forecast of an infectious disease outbreak ever made from space. The system relied on vegetation response signals measured from space. It measures how green a stretch of land is. The resolution is fine enough to pick up vegetation pulses smaller than a mile across. The Landsat sensors take that picture continuously, year after year. Earlier work by the same team had noticed the pattern. The vegetation signal appeared months before rodent population peaks, and rodent peaks appeared before human infections. Look at the desert from orbit, wait 12 months, and the outbreak shows up. The forecast proved itself again in the 2015-16 season. Advanced warnings of elevated hantavirus risk were sent out across the Southwest and Mexico. Cases in Colorado and Mexico rose in line with the alerts. Landsat is more than a passive science tool. It is, among other things, an active outbreak prediction system for one of the deadliest respiratory bugs in the Americas. The data gets processed, the risk maps get made. State and tribal health departments in the Southwest get briefed. The greenness over a stretch of New Mexico scrubland in 2026 is an early warning sign. It points to cases that will land in clinics 1 to 2 years from now. The setup is now reaching beyond academic forecasting. The same NOAA disease prediction program that issued the 2015 warnings runs on the current satellite feeds. The December 2025 alert for the Southern Cone drew on NASA precipitation and vegetation data alongside ground reports. State agencies in New Mexico, Colorado, and Arizona get early warning briefings. The signal goes from the orbital sensor to a county health office in a matter of weeks. The implication is bigger than it sounds. The agency known for moon landings and Mars rovers is also running the most accurate hantavirus forecasting system anyone has ever built. The system works. It has been right more than once. It publishes risk maps a year in advance, and it proves the map is no longer stable. For 30 years, hantavirus risk in the Americas followed a predictable geography: the U.S. Southwest, the southern cone of South America, and scattered forested regions in northern Europe. But that boundary is shifting. In 2025, CDC weekly surveillance recorded confirmed cases in Wisconsin and Nevada. Both states have almost no history with the virus. Louisiana has logged 2 unrelated cases. The detections placed lab-confirmed cases in the southeastern U.S. for the first time in the surveillance era. These aren't expansions into adjacent zones. They're appearing in new ecological contexts. Argentina is the most dramatic shift on the global side. Patagonia dominated hantavirus activity. It sat in the southern tip, in the cold Andean foothills with a notable rodent population. By the 2025-26 season, the center of gravity had moved. Buenos Aires province, the country's most populated, now leads the nation with 42 confirmed cases for the season. The disease is leaving the cold remote south. It is heading into the central agricultural belt, where peri-urban density runs much higher than in Patagonia. Europe is shifting too. In northern Sweden, virus activity continues to track forest edge ecosystems, but data shows an expansion into areas with lower historical incidence density compared to earlier decades. Germany and neighboring parts of Central Europe have seen increased outbreaks in forested districts following population cycles. The risk envelope is widening. As the zone moves into ground closer to population centers, it carries the disease into new bodies. Those bodies have even less prior contact with the bug. The remote communities that used to take all the hits had at least seen the carrier before. The new ground has not. The numbers reflect this too. Argentina's fatality rates were up to 39% in the 2025-26 season, running well above the 22% average. The more unfamiliar the system is to the host population, the higher the physiological collapse rate tends to be in severe cases. The boundary is not the only thing shifting. The population meeting the virus at that boundary is shifting too. For 3 decades, hantavirus risk in the American Southwest fell disproportionately on people with deep ties to the land. Ranchers, tribal communities, forest workers, and rural residents who had grown up in proximity to the carrier pool. They weren't immune in any clinical sense, but they were exposed repeatedly at low levels over years. But the population now entering the risk zone is different. Remote work migration accelerated during 2020 and has not reversed. The U.S. Census Bureau recorded net population growth in rural counties across New Mexico, Colorado, Montana, and Idaho through 2023 and 24. People are moving into hantavirus territory from coastal cities, from suburban environments, from places where the deer mouse is not part of the landscape they grew up in. They carry no behavioral familiarity with the pathogen. They're buying land, opening outbuildings, sweeping floors, and moving firewood in exactly the environments that carry the highest viral load. New Mexico's health department flagged this directly in its 2024 annual disease surveillance report. The department noted an increase in cases among recent in-migrants to rural communities compared to long-term residents. The gap isn't enormous, but it is consistent, and it is growing. The Yosemite cluster in 2012 was an early signal of this dynamic of urban visitors moving through a loaded environment without the background exposure that modified their response. The 2025 Mono County cluster repeated it. Workers contracted for short-term rural employment, brought in from outside the region with no prior hantavirus exposure history. The virus is not becoming more aggressive. It's not a new thing either. It's always been there. The only difference is that the media are now shining a light on it, and the panic is real. The difference is the population meeting it is becoming less prepared. And the deeper question is not severity at this point, it's the spread, which implies a cause. Something pushing the boundary outward, and it's global. Something that can operate bigger than any single ecosystem. A system that can influence rainfall, vegetation cycles, and rodent population dynamics across continents simultaneously. A planetary signal. When the equatorial Pacific warms, the entire hantavirus chain accelerates simultaneously across multiple continents. The American Southwest gets wetter. Patagonia responds. Central European forest floors change. All at the same time, driven by the same temperature shift thousands of miles away. That synchronization is not a coincidence. The El Niño Southern Oscillation, or ENSO, is not an occasional weather anomaly, it's a repeating planetary clock, and hantavirus runs on its schedule. That's the key connection. Because rainfall determines vegetation output determines food availability determines rodent population dynamics and affects the viral load in the environment. All of these factors determine the exposure risk. The full system operates on multi-year cycles, often ranging between 3 and 7 years depending on ENSO variability. The NOAA Climate Prediction Center can spot a developing El Niño 12 to 18 months out, well before any ground effects show up. That means the earliest signal in the hantavirus chain is not in the desert. It is in the Pacific Ocean. Temperature shifts in the equatorial Pacific can ripple through the atmosphere and change rainfall patterns around the world. Those changes then cascade into ecosystems that can drive swings in rodent populations and, with them, the risk of hantavirus exposure. The map is no longer describing where outbreaks happen. It's describing where they're being prepared. And that preparation follows a cycle no local authority controls and no city planning can redirect. The trigger is not in the ground. It's in the ocean. And it took a cruise ship in 2026 for the world to notice. Passengers isolated in cabins, emergency flights, health officials in protective gear, contact tracing across multiple countries. The vessel, the MV Hondius, became the center of international attention. The moment people heard virus and cruise ship, the comparisons to COVID started. But Hantavirus isn't the next COVID. It's different. It's brutal, but unlike typical diseases, it doesn't spread easily. That's why the better comparison isn't COVID or influenza, it's actually anthrax. Not because the diseases are similar, but because they both feel like localized disasters. Rare, environmental, hard to encounter in everyday life, but devastating when they strike. Hantavirus doesn't threaten worldwide lockdowns, but it creates concentrated kill zones instead. A remote cabin, a forest outpost, a campsite, a ship at sea. Suddenly, what we thought was safe, isolation, becomes a threat.
Thanks for joining me today. I hope you enjoyed the video, and if you want to see more videos like this, then please consider subscribing and turn on notifications. Really does make a difference. Thanks again, and I'll see you next time on MatPack.